busy with trigonometry. Today we have a mixed exercise. So now we must make sure that we understand everything about trigonometry. Let's just revise what we know at this stage. When we work in a right-angled triangle, this is opposite, hypotenuse, and adjacent. This is a right-angled triangle. There we have the three functions. Sine theta, which is opposite over hypotenuse, cosine theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent. How will I know which one to choose? Remember here, if this is your opposite and your hypotenuse. For cosine, it's that included angle, cosine. And when we work with tan, you have opposite and adjacent, no hypotenuse is involved. We ask ourselves two questions: which function, which method? Then we've learned now about any triangle, So if this is triangle ABC, the first important thing was that the sides have the small letters opposite the angle, have the small letter. And now we've learned four formulas here. The first one is the sine rule, which says A over sine A is equal to B over sine B. The second we will use for that. So we're looking now at exercise 9.1 on page 477. And this is now a revision exercise. So we must decide which one of all those formulas are we going to use. So we've got the picture there. In the triangle ABC, it is a right-angle triangle. Calculate the length of AB. Now we know finding that third side is then always Pythagoras. So it will be 17 squared minus 15 squared. If you press it with those brackets there, you immediately get the answer of 8. You must first do this exercise now and then mark it. The next one, number B, it's a right-angle triangle. Use trigonometry, calculate angle C. Now actually we've got all three sides, so you could use any one, but you must choose the correct one. So I've chosen cosine. So cosine C is adjacent over hypotenuse. How do we get angles? Which method? Second function, cosine, and C is then 28.1 degrees. Angles rounded to 1 decimal place. Number 2. Now, that number 2 is actually showing you Pythagoras because it's that theorem of Pythagoras that we have there. So we can say that 625, now remember this is the area. And so we can get the square root of that one and then the square root of 400. So if we subtract those two, you will get F, which is 15. So they actually gave you those squares already. Number 3. Again, we've got a right-angle triangle there. Explain why A and C is right-angled. Now, we do that by using Pythagoras. We must show that Pythagoras is working. That's how we can show that it's a right-angled triangle. So this is 169, which is 144 plus 25. And then we get that 169 is equal to 169. So Pythagoras is working. We test it. Number B, now they say, give your answer as a fraction. So they do not want the angle. They just want the ratio. So in this case, we must choose the correct sides every time. 12, 5, and 13. Now, they want cosine A. This is angle A, cosine A. So the question is, which two sides will it be? Included angle, so it is 12 over 13. That's all that they want on that one. And then the next one, sine C. Now this is angle C, and sine C is then also going to be 12 over 13. So you can see if we use those opposite angles, then sine and cosine will be equal there. Question 4. Now, here we've got 3 right-angled triangles, so we'll have to look very carefully there in which one we are working, but it is still right-angled triangles. This angle here is 37, that side 550, 420, and 56. Now, the first thing that we want to find now here is AB. AB. And we've got the 2 sides there. This is what we want to calculate, so it will be 550 squared minus 420 squared, and the answer that I got there was 355. You can just do the sum. Number B. Now we want BC. So now this is what we want to calculate, BC. Which function will you use? And I would say it is the tan function. Can you see the hypotenuse is not involved? So tan 56 is equal to opposite over 420. Which method do we use? Top times. So we will just multiply there, and it is then tan 623 meters that we will have there. The last one, number C, is to calculate DE. Now we're here. This is what we want to calculate. Which function will we use? Cosine. It's the included angle. So cosine 37 is equal to 550 over ED. And which method this time? Bottom divide. So it is 550 divided by cosine 37, and it is then, my answer is 689 meters. 698 meters. The next one, question 5. So you have that boat. Now, this sum is an interesting one because you have a right-angle triangle here and any triangle there. This angle is 18 degrees, 44 degrees, 30, and 80 here. So the angle of elevation is 18 degrees. There we have that one there. Give your answer to 1 decimal place. Now, in the first place, we have to calculate now AH, which is this side that you want to calculate. So which function, which rule are we going to apply? Because this is any triangle. It's not a right angle triangle. And we can work with opposite sides. So it will be sine, but you will need this angle because this angle is opposite the 80, not this one. So this is exterior angle, which is equal to the sum of the opposite angles. So this little angle here will be 26 degrees. It's important to get that first. So I'm going to use the sine rule, opposite sides, opposite angles. The one that I want to find comes on the left-hand top. So it is now AH. Now then I actually need AH over sine, and now we need, this is actually the angle that we need here, is that one. So it is then 180 minus 44, which is 136. So I need 136. I need the opposite side, and the opposite angle there is equal to 80 over sine 26. So can you see I need 2 angles in there to do that one. So we cross multiply here, and the answer is 97.1 meters. Number B, calculate the distance BH, the distance BH. Now BH is now this side here that we need to calculate. Now I can work in the right angle triangle there, and I can again use the sine function. So sine 44 degrees is equal to 30. This is now a right angle triangle over BH. Which method? Bottom divide. So it's 30 divided by sine 44. And this one's answer is then 43.2 meters. 43.2 meters. Question C. Hence calculate the distance BC from the foot of the cliff. Again, there's more than one possibility. I will use tan. So tan 44 is equal to 30 over BC. Which method? Bottom divide. It will again be a division one, which is then 31.1. But the question is now actually, hence calculate the distance BC from B to the foot of the cliff. So that's actually that whole distance. Well, if you want to find AC now, it will then 80 plus this 31.1, which is 111.1 meters. Right, grade 11. So now you can do the second part, which is now a little bit more difficult.
ShopRite is your home of low prices this Christmas with unforgettable savings on everything you need. Stock up this festive season with great deals. Like 2 kilos of Jungle Oats, only $49.99. And 2 kilos of Omaere, just $34.99. Don't miss out on unforgettable savings at the home of low prices this Christmas. Only at ShopRite. Lower prices you can trust, always.
Win free airtime with #LearnOn1. Share your comments on the lessons. WhatsApp your feedback, name and town to 081 200 6659. #LearnOn1. Invite learning in.
Continuing our lessons on trigonometry, and today we're specifically looking at bearings. Now there's 3 things that we need to know about bearings. The first thing is we always work with a north line, and the direction is north clockwise. You work north clockwise. So this is the direction that we're going to measure. The next important thing is you're looking at the from angle. If I say A from B or B from A, then it will be this angle here. From, that's where you should look at. Another thing is that at B we can draw a second north line, and those 2 lines are now parallel. So here you have co-interior angles. And then we give it as a 3-figure bearing. A 3-figure bearing. So that means, for instance, this one is 125 degrees. That's the bearing. If there's no 0 there, or if it's a smaller number, then we use a 0 in front for bearings. Okay. So we're looking now at try now 38. and this is on page 481, page 481. So you have to find the bearings B from A. So we're looking at the A angle there. Now the first ones are very easy. If you look at that one, it's a straight line. North clockwise will be 145 degrees. I get that, 180 minus the 35. Number B, so we have an angle like this. So this is a straight line which it's 180 degrees, and then we add this little angle here. So this one is 220 degrees. Number C, obviously that's just that 039. Look at the 3-figure bearing that we're using then here. Number D, so there it looks like this, and the only thing that you have is that this one is 250 degrees, 25 degrees. We know up to there is 270 degrees if we go north clockwise. So 270 minus the 25. So this bearing here is then 245 degrees. Number E, that one will be 360 minus the 53. So it's 307 degrees. I can also work with that 360 degrees there. And number F is then 270 plus the 47, which gives me 317 degrees there for that one then there. So that's just bearings north clockwise that we're looking at. The next one is now try now 39. Again they say find the bearing of A from B. So we're looking at B. So this one is now 35. This is A, this is B. So what we're looking at is this angle. That's the bearing north clockwise there. So what we can do here, what we know is that this angle, this is then co-interior angles because these two lines are parallel. So it means that this angle here, this one here, will be 145 degrees. And then we can say 180 plus 145, which is 325 degrees then for that one, number A. Number B, there's the north line. This time B lies here. There is A. We know that this angle is 45 degrees. Remember, we want A from B. So what we actually want is this angle here, from B, north clockwise, alternating angles because of the parallel lines there, and it is then 045 degrees. 045 degrees. Number C. There's my B. This one is 39 degrees. So what do I want? This is the bearing that I want there. So you can either the reason that this one, little one, is also 39 here, alternating, or you can find that one then there. So if I say 180 plus 39, then I have 219 degrees there, 219 degrees. Number D. So this one looks like this. Here we have this triangle, and point B is here. So this is the second north line that we have. This one is 65 degrees. Again, A from B. So this is what we want. There it is. And this one is alternating with this one. So it is 065 degrees there. Number E. There is A. Here is B. I draw the north line there. We know that this one is 53. So A from B. So the angle that I want to find is this one here. Co-interior 180 minus that one. And that is then 127 degrees. And the next one, number F. So we know that this angle here is 43 degrees. There is B. I draw a north line there at B. Again, my two lines will be parallel. So this is co-interior angles, and it will then be 137 degrees. So that's the basic things on bearings that we have there. So now we're looking at try now 40. Try now 40. And now we've got word sums, and it will always be good to draw a picture here to see what you have. A map shows 3 towns, D, E, and F. D is due north of F, so there's F, there's D, and E is due east of D. Now, that due east means a 90 degrees, directly east, directly north, that we're going there. So DF is 75, and the bearing of F from E. Now, the bearing of F from E is now this angle there, and that one is 245 degrees. And now we have to find D, find the distance DE, the distance DE. So this is what we have to calculate here. Now, we can find the size of this angle, and then that one alternates with this one, or then we can get that one because we need an angle inside the triangle. So to get this one, it will be 245 minus 180, that straight line there, and that is 65. So this one and this one is then 65 degrees. Now we have to calculate DE. I will use the tan function here. So tan theta is, or tan, we can actually say tan 65 degrees. We have theta is equal to DE over 75. Which method do we use? Top times, because this is a right angle triangle, and the answer will then be 161 meters. And then in the second place, B, they want EF. Now we have to calculate this one. We can work with a Pythagoras perhaps to find that side there. So EF. So EF is then equal to 75 squared plus 161 squared. I want the hypotenuse. That's why I add. And my answer is 178 meters, 178 meters. The next one, number 2. Now, there you have a picture looking like that. Now, let's redraw it. It's not a right angle triangle there. It looks like this. And then they formed right angle triangles everywhere there, so that we can see what's going on there. So this one is 64 degrees, this one 58, this one 42.3, that is the vertical distance there, and this one 15.4. Right, so the first question now here is, the ship leaves Port P on a bearing of 64 degrees. It sails for 58 kilometers to A, and then calculate how far is A north of P. Now you can see, now they say find PH. That's why they've drawn that right angle triangle there. Which function will we use? Cosine. It's that included angle there. So I can say that cosine 64 is equal to PH over 58. Which method? Top times. That's what we're going to use, and it is 25.4. Make sure that you first do the exercises before you mark them. Then A2. Now east of P, and now they say we have to calculate HA. So now we're looking for this. This is what we're looking, but we're still working in this right angle triangle there. Can you see? So this time I will use, well, you can use Pythagoras, or you can use sine, we can use anyone there. So AH is then equal to 58 squared minus 25.4 squared. And that gives us, as I say, you might use another function as well there. And it gives you 52.1 meters, 52.1 meters. Right, now B of that question. The ship then sails to the island B. So if we look on our picture, it now sails here to B, which is 5.3 kilometers south of A and 15.4. So now we have this right angle triangle there. And now they say, calculate BAJ. BAJ, so we work in this right angle triangle. We're going to use tan there. So tan A is then equal to 15.4 over 42.3. And it's an angle that you want, so it will be second function tan A is equal to 20 degrees. 20 degrees. And the next one. Now, number 2 there. The bearing of B from A. The bearing of B from A. Now, if we go back to the sketch, this is the angle what we want now. We know that that is 180, and we have this size of this one to be 20 degrees, so we can just add the 2, and that will then be 200 degrees. Now we look at number C. Angle KPB is 65 degrees, and we have to calculate the bearing of P from B. P from B. Now again, if we go back to our sketch, P from B means this is the angle that we want there. That is what we want to calculate there. Remember your north lines, that you work with your north lines, and that bearing is then 295 degrees. 295 degrees. Right, and we continue with number 3. The ship leaves Port B and sails 5 kilometers on a bearing of 120 degrees. Find the bearing of P from Q. So now we're working there. The easiest one will be to say that this angle now there is 60 degrees, and this is then 360 minus that 60, which is 300 degrees. 300 degrees. And then how far Q is east of P. Now Q east of P is, this is the line that we want to calculate there. So you can do different calculations. We know this one is 60 degrees. We can see here that this angle is 30 degrees then there as well. And we can use the sine function here to calculate that due east of P with sine then there. Let's say sine 30 degrees. No, sine